Hello, grade sixes. Welcome to the last unit of grade six math. We have statistics and probability in one lesson. Here we go. So, the first thing we're going to look at is a pretty easy concept. Okay, it's called using a questionnaire to gather data. So, think of a questionnaire. Okay, think of the word question in there. So, basically, a questionnaire is a question, okay, to gather data. Okay, it's a question with different answers, and you pick one, and with that, you can create graphs. You can do a bunch of stuff, which you're going to learn in the future here. So, here are some guidelines for writing questions for a questionnaire. The questionnaire should be understood in the same way by all people. Suppose you want to find out how much TV people watch. You think of asking, do you watch a lot of TV? Yes or no? People may interpret a lot as a different question. Okay, they might say, oh, is that every day? Is that what? So here what we're talking about is that you need some type of quantity. Okay, so a better question would be, how many hours of TV do you watch in a typical week? Okay, as you can see, we have hours as our quantity here, and it really gives the person some guidance to how many hours people watch. If you just say, do you watch a lot of TV? People are going to say, I don't know, what's a lot, right? So that's what we're getting at there. Okay, each person should find an answer she or would they choose, okay? She would choose, or he, okay? So what we mean by that is, okay, you obviously want to have more choice than just one or two things. So here we go. Suppose you want to find out people's favorite sports to watch on TV. You think of asking, what's your favorite sport to watch on TV? Hockey or baseball? Okay. Well, personally, my favorite is football. How do I respond to this? By giving my favorite sport. If you said, which is your favorite sport out of the two, okay, that makes sense. But if I want to know the favorite sport, okay, what I'm going to do is go, some people may prefer a different sport. Others may not watch any sports or on TV, so add more choices. So a better question would be, what is your favorite sport to watch on TV? Is it hockey, baseball, soccer, other, or none? Okay, what you'll see here is that there's the choice of none, okay, because maybe some people don't watch sports, and then other to give, obviously, more guidance to the question. Finally, the last criteria with the questionnaire, guys, is the question should be fair. It should not influence a person's answer. If it does, it is a biased question. Suppose you want to find out people's opinions on how often students should have phys ed classes. You think of asking, studies have shown that daily physical activity for children is important. How often should elementary students have phys ed classes? Okay. The question provides extra information that might lead a person to answer one way. So what we mean by that is you can't create a biased question, okay, as your questionnaire. You have to give everyone an opportunity, and the information has to be very non-biased, okay? So here, a better question would be, how many times a week should elementary students have phys ed classes? Never, once, twice, three times, four times, or daily. What this does is it gives an answer, okay? It gives people options, but it doesn't say that we need daily physical activity, because that's a biased question. You're basically saying that we need more phys ed than we have. So the last thing with questionnaires, guys, is Mia wanted to find out which Canadian singer her classmates like best. She handed out a questionnaire. She asked this question: who is your favorite Canadian singer? And she gave all those options. Avril, okay. Sorry, we have Avril, we have Susan, we have Nelly, we have Paul Brandt, we have Brian Mello. So, and we have other. Okay, so Mia recorded the results in a tally chart, and that's basically where the data comes in. Okay, so a questionnaire gives you give each person that same questionnaire, and then you take the information and use it as data. Okay, so here we have Avril Lavigne has 5, 6, 7, 8, 9 votes for the best artist. Okay, we have 1, 2, 3, 4, 5, 6, 7 for Susan. We have 5 for Nelly. We have 3 for Paul, and we have 2 for Brian, and we have other. We have some people. Okay, so here we concluded. Okay, a conclusion is basically looking at the data. What do you see? Okay, that Avril Lavigne was the most popular singer of those named. Mia's question was a fair question. She did not give clues about her own preference, nor did she try to influence a person's answer. Okay, and that's very important with questionnaires. You cannot influence someone, you can't be biased, and you have to come up with questions that reflect everyone's opinions and information and topics. So with this information, guys, what we can do is we can start graphing things, and that is the second part of this lesson. So the first part was easy. It was gathering data for questionnaires. Now we're going to go into interpreting graphs. Hard-Headed Helmet Company wanted to find out how many of its motorcycle helmets have been sold in the last 6 months. The company surveyed 10 bike stores in Manitoba. So we have the month here and the number of helmets sold, okay? And if you think of it that way, okay, you have the month, which is the x-axis, and the y is number of helmets sold, okay? Only whole numbers of helmets can be sold. For example, a store cannot sell 12 3/8 helmets. So this graph is a series of points that are not joined, okay? These data are discrete. There are gaps between values. Usually discrete data represents things that can be counted. From the table, we can see the greatest number of helmets was sold in July. So the big thing here, guys, is that we have number of helmets sold here, we have the month here, and our goal with this graph, okay, is not to connect all the points, even though you could. It shows like this, right? Okay, what it is it's showing you which is the month that sold the most, and here it is obviously July, okay? Now we can definitely just look at this data table and say the exact same thing. Our highest number is July, but if I was given a graph, okay, and I said, all right, we have to find out in the last 6 months when was the best month, I would look at this dot right here and say, wow, that's the highest on my graph. So this table and graph shows how Leah's height changed as she got older. Okay, so here we have, we have age, okay, and we have height, okay, and we go all the way from 2 to 19. Okay, and what we do is we can see that the age, okay, it goes up by 2 on the scale here, which is a good scale, okay, and it goes up 40 here on each one because my height goes from 80 all the way to 160, okay? And now what we did was we basically graphed it, and what we should have noticed was that 16, 17, 18, and 19, there is no growth, okay? It's all the same. This is another example of a different graph. So the big things here is consecutive points on the graph are joined by line segments, okay? We all know what line segments are now. Points on the line between the pod points have meaning. For example, it is possible for Leah's height to have been 117.5 when she was 6 years and 3 months old. From the graph, we see that from 2 to 16 years, 2 to 16 years of age, the line segments go up to the right. This shows that Leah's height increases. So, okay, when you're interpreting graphs, basically what we're saying here is that you're drawing a conclusion. So here, Leah's height increased, okay? From 16 years on, the line segments are horizontal. This shows that Leah's height has stopped increasing. She has stopped growing taller. This type of graph is called a line graph. It shows continuous data. What continuous data can conclude any value between data points? So here are the big things. Time, money, temperature, and measurements such as length or mass are continuous, okay? There's always going to be a continued data with it. Next, we have types of graphs, okay? And we're going to go through some of these now. So the first one is a bar graph, okay? And what a bar graph is you have data here, okay? And you have data here, number of chocolates and box. So from the bar graph, Tao knows that the bar representing box 3 is the tallest, okay? Right here, all right? So box 3 is the greatest number of red chocolates, okay? And that is 13, all right? Box 1 has the least number by looking at this, okay? Box 1 does, all right? So bar graphs, what they do, guys, is you have your box number here, kind of like your, let's say an input-output machine. This is your input, okay? And your output is here, and it goes up by 4s, okay? And what it's showing you is that there's 8 chocolates here, 12 here, 13 here, 9 here, and 12 here, okay? So, Manuel recorded the contents of his family's recycling bin. This table shows what his family recycled each week for 2 weeks, okay? So, we have week 1 and 2. Okay, and what you're going to notice with this one, guys, is that there are 2 bars in the graphs. This is called a double bar graph, okay? Manuel wanted to compare the data for week 1 and week 2. So he drew a double bar graph to display the 2 sets of data, okay? So here it's week 1, we have 21 and 23. So what I notice is we have 21 and 23 here, and that week 2 had more. Okay. The next one, glass items, we had 11 and 9, so week 1 won that one. Okay. Cans, we have 7 and 9, week 2 won, and week 2 won boxes as well. Okay. But my data is here. Okay. In my bar graphs, it shows me how much plastic there was, glass, cans, and boxes for week 1 and week 2. The big things here, guys, is that they're different colors, okay? And you have a legend, okay? What a legend is basically you have your blue here and your other blue here to represent what this is, and then item is our x-axis and y is number of recycled. So, from the double bar graph, Manuel knows that more plastic items, cans, and boxes were recycled in week 2, and fewer glass items were recycled in week 2. Manuel then displayed the data to show the total amount recycled over the 2 weeks. The data are discrete and there are sets of items, so Manuel drew a pictograph. Okay, and what you're going to see is a pictograph next. So what we saw, guys, is that we took week 1 and week 2's data, okay, week 1 and week 2, okay, and now we combine them into plastic, glass, cans, and boxes, okay. So this is what a pictograph is, guys, okay, right here, all right. And what they did was they drew a picture for 4 items, okay. So what we did was plastic items, okay. We drew 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of these, which 11 times 4 is 44. Then we had glass items, 1, 2, 3, 4, 5. 4 times 5 is 20, okay. Next we had 4, 8, 12, 16. We had 16 cans, which is the same here. And boxes, we had 4, 8, 12, 16, 20, 24, which is the same here. Since each number is divisible by 4, he chose to represent by 4 items. From the pictograph, Manuel knows that in the 2 weeks, more plastic items were recycled than any other item. Okay, we can see that. Look at how many more there are. Okay, in the 2 weeks, cans were recycled the least. Okay, so we had cans as our least. All right. So the big thing here, guys, is that you can take data and make different graphs. You have bar graphs, okay, which can be shown higher data, okay. Here, a pictograph works well because our data isn't a lot, okay, and we can make it 4 items here and it works, all right. A double bar graph compares, okay, and a line graph is always continuous data, all right. And those are the big things with this lesson. Hopefully you guys understand that. If you need to come see me, you can, but you have your packages to work on, okay, and that is that.